there's some data, and we've been asked to plot a scatter graph for the data. So I'm going to do it relatively roughly, but hopefully the idea is going to be fine because we can see the general shape of it. So we're going to plot x on the x-axis and y on the y-axis. We've got 3, 15. So let's say we have 5. Let's say these go up in threes, 3, 6, 9, 12, 15, because the highest one is 15 here. And let's say we do the same on the y-axis, 3, 6, 9, 12, 15. So our first point is going to be somewhere here. And our second point, 5, 12, so that's probably going to be somewhere here. Then we've got 8, 10, so that's going to be somewhere here. 11, 7, that's going to be somewhere here. And 15, 2, that's going to be somewhere here. And then it says a new student was found to eat 10 sweets, and we want to estimate. So the number of sweets eaten is x. So if we want 10 sweets, that's going to be about here. And we can go roughly maybe to an imaginary line somewhere over here. And if we go across, that's somewhere around 7 or 8. So we can say the answer is going to be somewhere between 7 and 8 minutes. So part B, 7 to 8 minutes. And if you drew your scatter graph a bit better, you might be able to get a more precise answer than that. And then here it says another student ate 30 sweets. So the problem with 30 sweets is that while we could extend this to 30 over here, we can't really extend this line over to 30 because we don't know what happens after 15 sweets. So that's called extrapolation. And the problem with that is if we just use this data to extrapolate, we're going to see that we'll get a negative number for the amount of minutes they spend doing homework, which obviously doesn't make any sense. So when we want to find information that's within the ranges of what data we have, that's called interpolation, and that's reasonably fine. But if we want to go outside of the range of the data we have, especially if it's quite far outside, that's called extrapolation, and that might not be a good way of doing things.